Hi there, this is the video on confidence intervals, part 2. And just like the previous one, I just grabbed the question out of the textbook. So this is question 8, page 275. A company produces regulation ultimate discs. Okay, I'm old enough. In my world, they produce Frisbees. The discs have a mean mass, okay, so this might be important, of 175 grams with a standard deviation of 0.9. Okay, just so you know, in my soul right now, I'm like, I need to draw a curve, but we'll see. Maybe we can get away without doing that. To ensure that few discs are rejected, the quality control manager must ensure the mean mass of the discs lies within the acceptable range of 174.8 to 175.2 grams. During each shift, a random sample of discs is selected and the mass of each disc in the sample is measured. We have a table over here. Boop, boop. That shows the sampling process. All right, what is a confidence interval and the margin of error in this company? All right, so it's surprisingly easy. There is our confidence interval. Sorry. $174.8 to 175.2 grams. Now, our margin of error. Normally, you're looking for where's the plus minus part? Well, I'll show you two ways to do it. One way, and that's what I think, is okay, it has to be in this range. So if I go, okay, so I'm going to do margin of error here. If I take 175.2 and I subtract 1, got a little excited. See, how when I get excited? Math is cool. You already know what that is. Whoopsies. 175.2 minus 174.8. 0.4. So remember, that's our range. So like the margin of error is plus a certain amount and minus the same amount. So if we take that and find the big difference, and we divide it by 2, whoopsies, 0.2 grams. Okay, so here's the mean. This is what I'm trying to say. And this is the lower value. And this is the upper value. Right? So from here to here and here to here are the same value. And if the whole distance is 0.4 and we divide it by half, we'll get that. Or option 2, margin of error. The book actually said you can go 175.2 minus 175 and you get 0.2. Okay, that's maybe a little bit easier, but my brain keeps working at this. So the margin of error plus or minus 0.2 grams. Hey, you know what? You could even go 175 minus that one, and you also get 0.2. Anyway, either one of those ways will give you your margin error. All right, next question. Approximately how many discs should be measured to ensure the mean mass is within 6.20 grams 99% of the time? (99% of the time) is 135. Oopsies. Hold on. I think I've got it. Literally. Textbook. Something's wonky. Okay. I don't know how. I mean, I cut and paste it. Hey, hello. Yeah. Yeah. I have no idea how the plus or minus ended up as a 6. So math is within plus or minus 0.2 grams 99% of the time. Getting freaked out. I had no idea where that 60 came from. Okay, so all we got to do is 99% of the time, we go up to our chart. You have to sample 135 discs. All right. Manager wants to save on labor costs by using a smaller sample, right? Because every one that they sample, they're going to have to find the mass of. She knows that any discs that do not meet the regulation standards can still be sold as recreational discs. Approximately how many discs should be measured to ensure the mean mass is within plus or minus 0.2 grams 90% of the time? Right, switch that down a little bit for you. 90% of the time, go up here, and that would be 55. How do you spell discs? There we go, SCS. That's all you're doing is looking up there. So does that make sense to you, right? If we need it to be right 90% of the time, you got to sample 55 discs. If you want it to be right 99% of the time, so even more accurate, you'd have to sample more. So the higher the confidence level you want, the more discs you're going to have to sample. Estimate the number of discs the company should measure to be confident the mean mass of the ultimate disc lies within the acceptable range 19 times out of 20. Remember, 19 out of 20. 19 divided by 20 is... All right, you guys see that? Love my calculator. I said 19 divided by 20. What does it give me? 19 out of 20. It's a lovely thing. 0.95. It's just a weird setting on my calculator. I keep fixing it and it keeps resetting itself. So that's 0.95, which is, whoopsies, we can see that, 95%. And if you go back, sorry, and I go back up here, 95% is 78. And there we go. That is our answer to the second part on confidence intervals. Bye-bye.